Apply and analyze angles. This video goes over basic geometric figures. This is for geometry, math 3050 at Georgia State, spring semester 2021. To begin, one of the reference materials we're using is going to be Bloom. We begin the lesson with remember, the bottom of the pyramid, where we recall facts and basic concepts. We move up into understanding, where we have the students explain ideas or concept. Then we move on into the core part of the lesson, which is apply, using information in new situations, and analyze, draw a connection among ideas. Here is the Georgia standard that we're using, where we're going to find area of right triangles, other triangles, quadrilaterals, polygons by composing them into rectangles or decomposing them into triangles and other shapes. Apply these techniques and concepts of solving real-world and mathematical problems. Here's our Common Core standard. And for transference, students will be able to independently use their learning to associate new material with prior knowledge to analyze and solve new problems. Barriers to these goals: students may not be able to access computers, Microsoft Office Suite, Google Docs, or other software. Students may not understand some abstract concepts. Essential questions. Students will keep considering what are the defining relationships between a point, line, segment, ray, or angle. Students will keep considering what rules distinguish geographic figures from each other. Students will keep considering under what conditions can an angle be defined as a line. Students will keep considering how are spatial relations, including shape and dimension, used to draw, construct, model, and represent real situations or solve problems. Students will keep considering what are the mathematical attributes of objects and how are they measured or calculated. Understanding. Students will understand that geometry can effectively describe naturally occurring patterns. Students will understand that identifying the properties of simpler components of geometric figures can help understand the composition, design, and properties of more complex geometric figures. Students will understand that one geometric figure can be used to generate another. Students will understand that there is more than one way to represent and understand relationships between geometric figures. Students will understand that some geometric figures can be identified by multiple terms. Students will understand that two geometric figures can be added to create another. Students will understand that two geometric figures can be subtracted to create another. Knowledge. Students will know that lines and line segments are made up of at least 2 points. Students will know that lines and line segments have midpoints that divide the figures equally. Students will know that you can combine two angles to create a third angle. Students will know that you can separate combined angles to create different angles. Students will know that angles are made up of two rays that share an endpoint. Students will understand that line segments, lines, rays, and angles make up more complex geometric figures. Students will know that acute angles are less than 90 degrees, right angles are 90 degrees, obtuse angles are over 90 degrees, and straight angles are 180 degrees. Skills. Students will be skilled at identifying the components that make up simpler and more complex geometric figures. Students will be skilled at building geometric figures by knowing how to connect points, which are then connected to line segments or rays. Students will be skilled at identifying a line segment, line, ray, or angle by definition, labeling, illustration, or symbols. Students will be skilled at finding the measure of a line segment by subtracting points. Students will be skilled at using a protractor to find the measure of an angle. Students will be skilled at adding or subtracting angles to find another angle. Students will be skilled at identifying acute, right, obtuse, and straight angles. Students will be skilled at associating material with prior knowledge to solve new problems. For our pre-assessment, before the lesson begins, students are to take this formative pre-assessment to gauge the level of their prior knowledge. Here's a link below. Here's an example of the assessment. As you can see with the perforation down the center, you can print this out and cut it into to save on paper. To continue with the pre-assessment, we're going to have a guided practice we're going to do with the whole class. So we're going to start using the Bloom again. We're going to start with remember and understanding angles. We're going to recall and recognize geometric figures or their components by definition, labeling, illustration, or symbols. We're going to ask the questions. We're going to allow the class to fill in the blanks. The symbol of AB can also be read as blank. It can also be read as line AB. Next question. The symbol above CD can also be read as, the answer is ray CD. The symbol above EF can be read as, the symbol above EF can be read as line segment EF. We read M parentheses EF with a symbol above it as the blank of blank EF. This can be read as the measure of line segment EF. We read the symbol in front of parentheses GHI as the blank GHI. This can be read as the angle GHI. We read M, the symbol XYZ, as the blank of angle XYZ. We read this as the measure of angle XYZ. Now we move on to engage and apply. Have students predict, calculate, and solve the measure of line segments. Here we go again. We want the students to find the midpoint. Using the figure above, C is the midpoint. As we move on to the next question, we want students to find the length of each segment. As you can see with the figure above, what is the length of line segment AD? We find the length of line segment AD by subtracting 4 minus 1, which is the same as subtracting D minus A. So how many units is it? 4 minus 1 is 3 units. Next question. What is the length of line segment BC? We look at the units. C is 3, B is 2. We subtract those to get 1 unit. Next question. What is the length of line segment EA? E is 5, A is 1. 5 minus 1 equals 4 units. As we move on into the lesson, we're still continuing to engage and apply with the students. Again, we're going to have the students predict, compute, and solve the measure of angles. Having the students use the protractor, let them find the measure of the angles listed below. As you see the angles listed, the students can very easily see where the rays cross the protractor and have them write this down on a sheet of paper, or you can have them answer as a class. But as they're looking at the protractor, they can very easily see all the measurements for the angles. As we move on in the angles, we want the kids to be able to find more complicated angles that do not line up directly on the protractor. We begin with the first angle, which has a measure of 25 degrees. You can very easily see how we can find that on the protractor. However, how do we find the measure of this angle? Because we're not able to use our base angle of 0 to find this angle. We can have the students use the measurements here, and they can subtract 25 from 50 degrees to get the angle of GDS. How about if we want the children to find this angle? Again, you can see how the protractor lines up, and we'll just have the students subtract the angles where the rays cross the protractor. 105 minus 50 degrees equals 55 for this angle. As we move on to another angle, we see where the rays cross the protractor's measures. 140 minus 105 gives us 35 degrees for this angle. As we continue on to our last angle, we can see where the rays intersect the measures. As you can see, the protractor has two measures, one on top, one below. We can use the top measurements to subtract 180 degrees minus 140, which gives us 40 degrees. Or we can use the bottom numbers, where 40 minus 0 degrees gives us the same 40 degrees. Now we're moving on to explore and analyze. Here we have the students continue by breaking information into component parts in order to examine it and develop divergent conclusions. So pretty much we're trying to see if the students can take what they've already learned and use it in different ways to solve new problems. Here we're trying to find a measure of angle GDE. This is a larger angle here. As you can see, it's made up of two smaller angles. And here we can use the protractor to measure the angle, which gives us the measurement of 50. But you're not going to always have the protractor, so I'm going to show the students how to add two angles to find a larger angle. Here we're going to add angle first, GDS, which you can subtract 50 minus 25 degrees gives us 25. Now we find a measure of angle SDE, which if you subtract 25 degrees minus 0 gives us 25. So the larger angle of GDE, if you add the two smaller angles, gives us 50 degrees. And that's where we're going to end the lesson. I want the students to go home with this post-evaluation, and they're going to do this as homework without any further help. Find those complicated angles which are kind of floating and you can't use the base angle anymore, or you're trying to add two angles together to find the unknown angle. We can also, as a differentiation or to extend or find other connections, have the kids come up with their own real life applications for what they're learning today. And I purposely did not think of anything myself. I want to get the lesson to the point where kids can use the knowledge I've already given them and then start developing that to at least initially try to use that to figure out the answer with very little help from me. Here's my reference material for the lesson. And that's the end of my lesson. You can subscribe, and here's other lessons that I put together if you're still interested. You take care and thanks.